Alright, if you are watching this video, that means that you need help with pre-bronze or you missed pre-bronze in general. So we're going to go through here. So, the first thing that we're going to do is define some vocab words, and you're not going to know what those vocab words mean. You're going to get the definition, but you're going to be like, why do I care? And that's okay, because you're going to learn it in a little bit. So the first one is Hund's rule, and that rule states that electrons and an orbital prefer to be unpaired. In an orbital, prefer to be unpaired. And what I mean by this is, so here's my memory trick. If you were here and you were sitting on the rows of the bus, and these are 2 seats on the bus, and there's 2 seats right here. And on this seat, there is a person sitting here, and this person smells. Are you going to take this seat, or are you going to take one of these two? You're probably going to take one of these two. And so that's my memory trick for that one. So do not sit next to the stinky person. Alright, the off-bell principle for this one means that you fill all lowest orbitals before increasing energy levels. So before moving up. So this one, if you're building a house and you get the first and second stair, you can't get to the 4th floor without building the stairs to the 4th floor. So that is the started from the bottom rule. So to get to here, you have to start from the bottom. And the last one, I don't have a great memory trick for this one, but it says electrons in an orbital have opposite spin. Okay, so electrons we draw and they look like these little half arrows. It just means that they're facing opposite directions. Think of it like a battery pack where you put a positive side and then the other side, the positive side is on the opposite direction. It just means in one box, which you'll see that they're on the opposite direction. So here, in a neutral atom, the number of electrons is equal to the number of protons. Okay, and in the Bohr model, electrons orbit the nucleus in energy levels. So going here, you can't really see this, but it was in color. There's 3 right here. So my orange ones are my protons. There are 3. The electrons are these tiny little dots. There are 3. Neutrons, we have 1, 2, 3, 4. So the atomic mass is the protons plus the neutrons, so that is 7. So, electron configuration is all about finding where the electron is. Bohr was kind of right. He was kind of right about energy levels. So if you think about a stadium, imagine that you're at your favorite sport right now. So for me, I'm going to think that I am at a hockey rink. And my energy levels are my rows. Okay, those are finite. They don't change. But then I can change my section. So you can have sections along them, and that's what an orbital is. So here, an orbital would look something like this. So I can guess which orbital it is, and I can guess which energy level, but you don't really know because they're moving. So in school, say that you're the electron, okay? Now here, the energy level would be the grade level, so you're in 9th, 10th, 11th, or 12th grade. And your section, your orbital would be your classes. So if I know you're a 10th grader, I know that you're in one of 6 classrooms at any given moment, but I don't necessarily know. So I could say, like, I'm just going to use a random name. I could say that I know that Brian is in 12th grade, and I could say Brian has English during his first period class, and I could be totally wrong. Brian may not have English, or I could be right, but there's a chance that he's in one of those 6 classes. Okay. So, the orbital names, they're really easy. Make sure you're writing this in lowercase. They're S, P, D, and F. And they hold 2, 6, 10, and 14 electrons. And then you are going to flip to your page 41 for the rest of these notes. So, the arrangement of electrons in the atom is called the electron configuration, much like the title of this module. I did that on purpose. Electrons surround the atoms in orbitals. So this, we can assume that they're on an energy level, but we don't necessarily know exactly where they are because electrons are always moving. So the first thing to do is find the total number of electrons. Then you're going to figure out how many energy levels this has. So the row of the periodic table is equal to the energy level. If an element is in the second row, it has 2 energy levels. If it's in the first row, it has 2 energy levels. If it's in the third row, it has 3 energy levels, and you go on from there. So we're going to see what we do when we fill out this table together. So these are the first 2 rows here. So I'm going to look here for the number of electrons. I'm going to go to the periodic table and I'm going to type in, or I'm going to find the atomic number. If you're doing this online, you would go to ptable.com. And then you find the electrons there. So oxygen has the atomic number of 8. So you need 8 electrons. Fluorine has the atomic number of 9. So it's 9 electrons. Magnesium is 12. Phosphorus is 15. Argon is 18. Then if you look on the horizontal rows of the periodic table, so this is the row that's horizontal, that goes this way. Oxygen's on the second, fluorine the second, magnesium the third, phosphorus the third, argon is the third. All right, so now these are your orbitals. There's 1s, 2s, 3s, 2p, 3p, 4s, 3d, and 4p. So we're going to fill this out. 1s can hold 2 electrons. Now, oxygen has 8 electrons, so that means that I have 8 electrons to place. So I'm going to put the first 2 in my very bottom row. So my first 2 will go into 1s, because that can hold 2. Now I have 6 electrons left. 2s also holds 2, so I have 2, I'm going to put 2 in there. Now I've placed 4 electrons, because 2 plus 2 is 4. So I have 4 left. 2p can hold 6. Is 6 a greater number or a smaller number than 4? It is a greater number, which means that I can fit 4 right into that box. Now for fluorine, it's the same thing. 2 and 2 again, that's 4 electrons. I have 5 left. 2p still holds 6, so I'm going to end there. And then that means it's just 5. Now let's try magnesium. I have 12 electrons to place. So I'm going to put 2 in 1s. Now I'm going to put 2 in 2s. That's 4, so I have 8 left. 8 is actually bigger than 2p, so that means I'm just going to put 6 here because I'm going to max it out. And now I'm going to put 2 in 3s. So 2 plus 2 plus 6 is 10, plus 2 is 12. All right, now phosphorus is 15, so that's a 2, and a 6. That gets me 10. And then a 2, because I'm going to max out 3s right there. And then I have 3 left, and 3p can hold 6. So I can put all 3 in 3p. And my last one is argon, 2, 2, 6, 2, 6. And I maxed out 3p there. So now you're going to see what it looks like to actually fill these in. So we're going to do 38. And then you should already have 40 because we went over it. If you don't have 40, that's one where I want you to try it and check with your peers. So page 38 is the first page of this packet. You're on the page that looks like lithium. So lithium, I go to my periodic table and I find out lithium has 3 electrons. So I have 3 electrons to place. And I indicate that with my little arrows that don't match. So these are my electrons that I need to place. Okay? So I'm going to put 1 in the 1s box because you start from the bottom. Now, I can't go to 2s because 1s isn't full yet. Each one of these little boxes can hold 2 electrons. So I'm going to put it backwards up there. So that means I've crossed off, I've placed 2 of my electrons. Now my third one is going to go right on 2s, and then I'm done. I've placed my 3 electrons. So nitrogen has 7 electrons. So I'm going to put this here. 1, 2, 3, 4, because you max out the lower levels before you move up. Now here's where this gets tricky. On 2p, I have enough space for 6 electrons, but I'm going to not sit next to the smelly person on the bus if I don't have to. So you're going to fill it out as 1, 1, and 1. but you still keep it in the 2p level. Okay, neon, I look on the periodic table, it has 10 electrons. I'm going to do the same thing. 1, 2. Okay, I have 8 more to place. Then I'm going to go to my 2s box. 1, 2. That means I've placed 4 electrons, so I have 6 left. If I can fit 2, 4, 6 here, that means these are all going to end up in the 2p box, but I'm going to separate them out so that I don't make any mistakes. 1, 2, 3. I have now placed 7 electrons. So I'm just going to go 1, 2, 3 for 8, 9, and 10. So while this box got filled eventually, we want to be careful to only do it one at a time. All right, sodium has 11 electrons, so it's going to look a lot like this. So I'm going to get it to the 10 first because I know that's right. 1, 2, 3, go back, 4, 5, 6. 10 electrons. My 11th electron goes to 3s. It's just my little Lone Ranger. All right, we're going to go over page 40 just in case you guys need this from today. So phosphorus is 15 electrons, calcium 20, titanium 22. All right, 1, 2, go to 2s because the 1s is full. 3, 4, 5, 6, 7, 8, 9, 10. I have 5 more electrons to place. 1, 2, and then I'm going to go to 3p and spread them out. 4, 5, 1, 2, sorry, 3, 4, 5. And I spread these out because you don't sit next to the smelly man on the bus if you don't have to. Calcium is 20. 1, 2, 1s is full, so I can only go to 2s. Now I'm going to fill up 2p, and that will get me to 10 electrons. 11, 12, 13, 14, 15, 16, 17, 18. Now here's the tricky part. I've filled up 3p. I have 18 electrons. Do my next 2 electrons go into 3d or 4s? And the answer that you're saying in your heads, because I know you've got this and you're so smart, is 4s, 1 and 2. And that's my 20. So you fill up 4s. So it goes 3p to 4s, then 3d. So we got one more to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it just looks like calcium now. And we got 2 more to place, so we go back to 3D like our pathway right here. And you're spreading them out so you don't sit next to the smelly person on the bus. They each get their own box. And that is pre-bronze for you. Oh, happy day.